Hello, my loyal listeners and hopefully one day watchers, and welcome to the Biomimicry podcast, where I discuss how nature inspires human innovation time and time again. Imagine standing on a rocky shoreline. Waves are crashing against the rocks, the wind is blowing, and everything around you is soaking wet. Yet somehow, tiny mussels stay firmly attached to those rocks through storms, tides, and constant waves. They don't wash away, and they don't let go. So how do they do it? And more importantly, what if engineers could copy that natural glue to help surgeons close wounds, repair leaking ships underwater, or protect bridges from corrosion? I'm your host, Gus, and today we're exploring Mussel-inspired Adhesives, one of the coolest examples of biomimicry. We'll look at how this natural glue works, how scientists recreated it, and why it's changing medicine and industry. Now, let's start with the mussel itself. Unlike barnacles, which permanently cement themselves to surfaces, mussels produce tiny protein threads called Mussel threads. At the end of each thread is a sticky plaque that acts like a natural superglue. Scientists discovered these plaques contain mussel foot proteins, which are rich in an amino acid called dopa. Dopa is the key ingredient that allows mussels to stick to wet, rough, and slippery surfaces, where ordinary glues simply don't work. Nature solved the problem engineers had struggled with for decades, creating an adhesive that actually works underwater. Now, once scientists understood how mussels accomplished this, the next question was obvious. Can we build it for ourselves? Turns out, we can. Rather than using actual mussel proteins, researchers develop synthetic materials that mimic the way dopa works. Manufacturers create these adhesives so they stay workable during application, but quickly harden once they're in place. It took years of research to make these materials reliable enough for real-world manufacturing, but today they're being used in several different industries. One of the biggest applications is medicine. Traditional stitches and staples work well, but they can damage tissue and are difficult to use on wet surfaces. Mussel-inspired adhesives can bond directly to wet tissue, making them promising for sealing wounds, attaching implants, and reducing bleeding. Outside the hospital, these adhesives are also useful in marine engineering. Imagine repairing a cracked pipe underwater or sealing damage on a ship that's still in the ocean. Most adhesives wash away before they can cure. Mussel-inspired adhesives don't. Engineers are also exploring these materials for protective coatings on bridges, pipelines, and other structures exposed to harsh environments. It's interesting to see how this technology has evolved. Researchers first focused on understanding why mussels stick so well to rocks. Once they discovered the role of dopa, engineers began designing synthetic versions that could be manufactured consistently and used on a larger scale. Today, the focus is on improving durability, lowering production costs, and making these adhesives safe enough for medical and industrial use. That's what transforms an exciting laboratory discovery into something surgeons and engineers can actually depend on. Now, who is making these products? Much of the original research came from universities like MIT, Stanford, Northwestern, and the University of California, Santa Barbara, the biggies. Since then, biotechnology companies and materials manufacturers have worked to bring these adhesives into medicine, marine repair, construction, and protective coatings. It's a remarkable journey from tiny shellfish on a shoreline to products used in hospitals and industrial facilities around the world. It's actually incredible, and it's truly hard to believe. Of course, there are still plenty of challenges. Researchers continue improving how long these adhesives last, how well they perform over time, and how they can be manufactured consistently at large scales. Medical products must also go through extensive testing before they can be widely used. Like many biomimicry technologies, inspiration from nature is only the beginning. It takes a lot of hard work and dedication from these engineers to actually bring those ideas to light. Engineering is truly what turns that inspiration into practical products. So, the next time you walk along a beach and notice mussels clinging to the rocks, remember, there's an incredible engineering story behind those shells. A simple marine organism evolved one of nature's strongest adhesives. Scientists uncovered the secret behind dopa. Engineers use that knowledge to create new materials that help heal patients, repair structures underwater, and protect important infrastructure. That's biomimicry at its best. learning from nature and using engineering to solve real-world problems. Now that's all the time I have for you. Thank you so much for listening. I really appreciate your viewership, and I will see you in the next episode. Bye-bye.